All right. Welcome everybody to my session about infrastructure as code for your Azure data solution by using Terraform and Azure Resource Manager. Before I'm going to start with my presentation, I'm going to give a small introduction about myself. My name is Sjoerd Borneman. I'm a data engineer / consultant at InSpark. And InSpark is a company that helps organizations accelerating their digital transformation with impactful Microsoft solutions and expertise. And as a data engineer / consultant, I am involved in various data projects, for example, designing, building, and implementing Azure data solutions in the cloud for our customers. All right. So what is the goal for today? As many of you know, Azure Data Solutions comprises of different components, which makes it difficult to configure them consistently over different environments and also hold accountability for every change. So the use of manual infrastructure management greatly increases the likelihood of discrepancies, which we want to avoid as most as possible. Unfortunately, this also happens in Azure. For example, forgetting to set the correct access control list entry for your data lake folders and all those kinds of things. So this is an error-prone and also a lengthy process when you want to deploy an Azure data solution. And with infrastructure as code technologies such as Terraform and ARM templates, it is possible to deploy all the necessary components in a predictable and repeatable fashion. Important concepts such as security, networking, your entire data lake layout is managed and also versioned. So for this session, my goal is to take you through all the necessary steps to take control of your data solution deployments. I will address the what, the why, and the how when using Terraform and ARM templates for your Azure data solution deployments. So first, we are going to start with the infra as code tools. So why use infrastructure as code? Infrastructure as code uses a high-level descriptive coding language to automate the provisioning of your IT infrastructure. This automation eliminates the need for developers to manually provision and manage database servers, operating systems, database connections, storage, and other infrastructure elements every time they want to develop, test, or deploy a software application. So in an era where it's not uncommon for an enterprise to deploy dozens or maybe hundreds of applications into production every day, it is essential for an organization to automate infrastructure in order to control your costs, reduce risks, and respond with speed to new business opportunities. And infrastructure as code makes this automation possible. Also, with infrastructure as code, an essential DevOps practice, and indispensable for a competitive-paced software development team, it enables DevOps teams to rapidly create and version the entire IT infrastructure in the same way they version their source code. So what are the benefits? By simplifying provisioning and ensuring infrastructure consistency, infrastructure as code can accelerate every phase of your software delivery lifecycle. If the deployment process is automated, it will be significantly faster, since a computer can carry out the deployment steps much faster than a person can be, and also safer. Because this process is automated, it will be more consistent, more repeatable, and not prone to manual error. You can also store your infrastructure as code source files in your version control, which means the entire history of your infrastructure is now captured in your commit log. This becomes a powerful tool for debugging issues. For example, when a problem pops up, your first step will be to check the commit log and find out what changed in your infrastructure. And your second step may be to resolve this problem by simply reverting back to a previous known good version of your infrastructure as code. So which tools I'm going to discuss for this session? It is very important to know for Terraform and Azure Resource Manager template that both these infrastructure as code tools are standalone infrastructure as code tooling. You can use them both, but you can also use them separately when you only want to use, for example, ARM templates or Terraform. It's entirely up to you. So first, we are going to zoom in on Terraform. Terraform is an open source tool created by HashiCorp and written in the Go programming language. It is a declarative provisioning and infrastructure orchestration tool that lets engineers automate the provisioning of their cloud-based or on-premises infrastructure. You can use Terraform to deploy your infrastructure locally or from a build server or just about any computer, and you don't need to run any extra infrastructure to make that happen. This is because under the hood, Terraform makes certain API calls on your behalf to one or more providers such as Azure, Amazon Web Services, Google Cloud, OpenStack, etc. So how does Terraform know what API calls to make? The answer is you create Terraform configuration files, which are text files that specify what kind of infrastructure you wish to create. So these configurations are the code in infrastructure as code. So here's an example of a Terraform configuration file. Even if you've never seen or used Terraform code before, you shouldn't have too much trouble reading it. This snippet tells Terraform to make API calls to Azure, to deploy an Azure SQL server, and then assign an Azure Active Directory group as the Active Directory administrator of that specific SQL server. In just a simple syntax, you can see this, this specific deployment. So you can define your entire infrastructure, such as servers, databases, load balancers, your entire network topology, and so on, in Terraform configuration files, and you can commit those files in your version control. After that, when you define your entire IT infrastructure, you could then run certain Terraform commands, such as Terraform plan, which generates an execution plan which specifies what actions Terraform will take to achieve the desired infrastructure. And after that, you can run the Terraform apply command, which deploys that specific infrastructure that you defined in your configuration files. So when someone on your team needs to make a change to the infrastructure of your data solution in Azure, instead of updating that infrastructure manually and directly on the servers, they make the changes in the Terraform configuration files, when you check those changes in, you will validate those changes through automated tests and code reviews. You commit the updated code to your version control, and then you can run the necessary pipelines to deploy those changes. So the next tool is the ARM templates. Azure is managed it's entirely managed using an API. Just like Terraform, Azure Resource Manager templates is an infrastructure as code tool, which you can use to provision your infrastructure. ARM templates are the true definition of your Azure resources. So an Azure ARM template is basically a JSON file that defines the infrastructure and configuration for your Azure resource deployments. ARM templates also uses a declarative syntax. In the ARM template, you specify the resources you want to deploy and the properties of those resources. So here's an example of the structure and syntax of an ARM template file. Important for this session, we are focusing on the following attribute. That is the parameters attribute and the resources attribute. In the parameters attribute, you specify the values that you provide when you want to customize your resource deployment. And in the resources attribute, you define the resource types that you want to deploy or update in a specific resource group or subscription in Azure. So here's an example of an ARM template file. And this snippet shows you how to enable Azure Defender for an Azure SQL database with vulnerability assessment notifications. So let's break this file down. At the top, we have defined 4 parameters, which you can pass on as value to customize your ARM template deployment without changing code itself. After that, we have the resources attribute, which defines 2 types of resources. First is to enable Azure Defender for a specific SQL database. And after that, we enable the vulnerability assessments with the second resource. Later on this session, I'm going to do a live demo by deploying this ARM template with Terraform and also enabling a specific Azure SQL database. So then I will zoom in more on this specific ARM template file. So small recap. So far, I've shared with you what is infrastructure as code and why do you use it. what is Terraform and what are ARM templates. Next up, I'm going to show you how to provision an Azure data solution. All right. I'm going to give a small explanation about the solution that I'm showing on the screen. We are going to deploy this entire Azure IoT data solution in Terraform and in ARM templates. So what are we looking at right now? First, we want to deploy an IoT hub because we want to extract the IoT data that's been generated from our sensors. After that, we are going to deploy an Azure Function App because we want to add some logic before loading the data in a data lake. Also, of course, we are going to deploy an Azure Key Vault because we want to store sensitive data in a secure manner. After that, we are going to create an Azure Stream Analytics because we want to do some real-time analytics in Power BI, and Stream Analytics enables you to do that, and also to add some logic to the data if we want to. For storage, we are going to deploy an Azure Data Lake. And last but not least, we are going to deploy an Azure SQL database so we can structure our data and make it ready for analysis. So where do we begin? First, we are going to set up our Terraform solution. And first, we have to create a storage account in Azure to host your Terraform state files. But what are Terraform state files? So for Terraform, when you are going to deploy a solution in Terraform locally, Terraform needs to make a comparison between your configuration files, so the desired infrastructure that you want to deploy, and also Terraform has to know what kind of resources already live in Azure. So Terraform uses state files, which for this example, we are going to store in Azure. And in the state files, your entire infrastructure is being stored in a specific state file. So you can see it as a blueprint of your existing infrastructure. So Terraform uses this state file to make the comparison between your configuration files and what's already active in Azure itself. So when we have created the storage account, we are going to create a container to store our state files. And after that, we are going to save the access key of the storage account because we will need it to make sure that our Terraform solution can access the state files in Azure. So when we are going to start creating a Terraform solution, we have to create some Terraform files. And as you can see in the slide, I have an example of how you can design your directory. But first, we have to start with a main.tf file and a variable.tf file. You can choose whatever name you want for these files, but as you can see in the community of Terraform, most solutions have a main.tf file. It's also possible to use modules, but for this session, I'm going to skip that part. But with modules, you can modularize your Terraform script so it's more readable and accessible. All right. Yes, so in our main.tf file, we are going to write some Terraform code to make the connection to our storage account where our state files are being hosted. So we have to write a Terraform code to make that specific connection. So as you can see on the slide, we tell Terraform we make a connection to Azure, and we have to pass 3 arguments to make sure that the connection is being made successfully. We have to name the storage account, name of the container, and also the name of the key of the blob that we are using. After that, we have to authenticate, of course, to Azure. And there are multiple ways to authenticate with Terraform to Azure. For this example, we are going to authenticate by using a service principal. And as you can see, when we want to do that, we have to pass on some certain environment variables. First one is the ARM access key, which we have saved in the earlier slide, which contains the access key to our storage account. And after that, we have to declare the client ID and the client secret of the service principal that we want to use when we are going to authenticate to our Azure environment. After that, we have to define the tenant ID. And after that, we have to define the subscription ID. So when we have that specific part set up, we can run some Terraform commands. First, we are going to run the Terraform initialize command. And this basically tells Terraform to install dependencies that you defined in your configuration files. And when everything is run successfully, you will receive a message from Terraform that the initialization has been run successfully. So when we have initialized our solution, we can start by creating a workspace. This is very important because when you have multiple IT infrastructures managed in Terraform, you want to create a workspace for each environment. Otherwise, you will have the risk to override some certain infrastructure, and you don't want that. So for this session, we are going to create a workspace, but first we are going to run the Terraform workspace list command to see which workspace is right now enabled in our local terminal. So for now, as you can see, the default workspace is assigned, and we are going to run the Terraform workspace new event demo command to create a specific workspace for this session. And as you can see, when you run the Terraform workspace list command again, you will see that the event demo workspace has been created. So when you go to your Azure portal, you will see that after you run the create workspace command, Terraform automatically creates a state file in your storage account with the name of the demo, which contains the blueprint of the infrastructure that you want to deploy from that specific workspace. So that is the setup of your Terraform solution. And now we are going to create some variables to customize our IoT data solution deployment without changing the code itself. So these input variables allows Terraform resources to be customized without changing the code itself, and also allowing the Terraform code to be shared between different configurations. So for this specific solution, I'm going to declare 3 variables. I want to pass on the resource group name where I want to deploy the IoT data solution to. I want to define the resource group location and also the tenant ID. After that, when we created the variables.tf file, I'm going to create a specific Terraform variable file which contains those values for the variables that I'm going to pass on. So when we have created our variable files, we can start by creating the Terraform code itself. So this is the cool part. We are now going to define our entire IoT data solution in Terraform. And we are going to start by creating a resource group. So how does a Terraform resource look like? How do you build one? First, you will have to start by assigning the Terraform block type. This tells Terraform what kind of block you are going to create. Because we want to create a resource in Azure, we are going to use the resource identifier. After that, you will have to assign a specific label, which tells Terraform what kind of resource you want to create. So for this example, we are going to create a resource group. And the second label, we can assign a name of the specific resource, which we can use later on for other Terraform resources to make a reference. All right, so when you have defined this part of the Terraform block, you will have to pass on some certain arguments. You have some mandatory arguments. These are arguments that you have to pass on to be able to create this specific resource. And then you also have some optional arguments which you can assign some values, but are not mandatory to create a specific resource. For example, when you want to add some text to the resource group, that's a specific, optional argument, but it's not necessary. All right, so for this specific Terraform resource, we are going to create the resource group. We have to pass on the name of the resource group and the location. And I'm going to do that by referencing to our variable files by using the var.resource group name argument name, which contains the value for our resource group. Also in Terraform, it's possible to use the locals block. And in the locals block, you can define variables expressions, which you can use multiple times without repeating the code itself. So for this solution, I want to enforce a specific naming convention, which contains this name and 2 variable strings I can add to this one. So I'm going to use this resource name prefix variable for every resource that I'm going to create to enforce a specific naming convention. So how does that look? All right. We are going to start by creating the IoT hub. And as you can see, the IoT app also has the mandatory argument name. And by using the format function and passing the local expression, I can generate a specific name for our IoT app. And I'm going to do this for every resource because I want the entire data solution to have the specific name convention because yeah, that's what my superiors told me to do. Or you want to use it for some certain policies that are being used in Azure. So for this example, I'm simply using an expression which I can repeat for every resource that I'm going to create. After that, I have to assign the resource group name because when I create an IoT app, it has to live under a specific resource group. And I can define the resource group name again, but that's not best practice. You can create a dependency by referring to the first label, the second label, and then extracting the attribute which you want to use for that specific argument. So for this example, I'm creating a dependency and extracting the name of the resource group and assigning it to the IoT Hub resource. So what does this do? When you create a dependency, I'm going to tell Terraform that first you will have to create the resource group, and then you will have to create the IoT Hub. So you can orchestrate your deployment by referring to other Terraform resources. Also, every resource has some resource-specific arguments. And for the IoT app, I am going to configure the stock keeping unit. I'm going to add some IP filter rules, and I'm going to add some text because I want to use some Azure policies later on in the solution, or for maybe resource management or audits. So that is the IoT hub. After that, I'm going to create an Azure data lake, and as you can see, I'm going to use the same function. To generate the name of the data lake. We have some resource specific arguments where I'm going to enable the data lake Gen 2. And I'm also going to enable HTTPS because that's a more secure way to create a data lake. After that, I'm going to create an Azure Stream Analytics for the real-time editing of the data and also using it for analytics in Power BI. And as you can see, also the Azure Stream Analytics has some resource-specific arguments, and I can define a specific query job in the configuration of Terraform. So you won't have to write this specific query in the portal. When I already know what kind of logic I want to use on the streaming data, I can define this specific query in Terraform. So when I'm going to deploy the solution, the entire Stream Analytics job is already configured and ready to use. After that, I'm going to create an Azure function. An Azure function is a little bit more tricky because you have to deploy multiple resources to create an Azure function. The first one is the Azure storage, because when you create an Azure function, the Azure function needs to write certain logs and other system-specific data to a storage account. So we are going to create a storage account. The second component of the Azure function is to create an Azure app service plan, which tells you what kind of hosting plan you want to use. And for this resource, I'm going to create an Azure service plan with the premium tier. And the third and last component for the Azure function is to create the Azure function itself. And as you can see right here, we have some resource-specific arguments again. We are going to enable the authentication settings, and we are going to use the .NET runtime. And also what's very cool is when you use an Azure function app, you will have to configure some certain application settings. For example, connection strings. Normally you will do this manually in the portal, and locally you have some config settings file where you define these connection strings to debug it to run your application locally. But with Terraform, we can already define these application settings and already make the connection for our Azure function. So for this example, I'm already configuring the IoT Hub connection string in our application settings, and also the data lake Gen 2 connection string. So our developers can already start programming their logic in the Azure function app and make the connection to the data lake without configuring the connection themselves. And I'm doing that by using another dependency. The last resource we are going to create is an Azure SQL Server. As you can see, you can pass on the credentials of the SQL admin user. In this example, I'm going to use some dummy information. And when we created the Azure SQL server, we are going to create a specific Azure SQL database. So this is the entire IoT data solution that we saw in the solution design. And now we are going to deploy this solution. And we are going to do that by running some Terraform commands. So by running the Terraform plan command, you are going to generate an execution plan, which tells you what kind of resources Terraform is going to create, update, or delete. So this gives you a very clear image of what you are going to deploy before actually deploying it. So when you run this command, it should look something like this. So I'm going to start by running the Terraform plan command, and I'm excuse me, and I'm going to refer to the variables file which contains our variable values. And when you run this command, you will see in the terminal that Terraform is going to generate an execution plan. And when this execution plan is done, you will see that Terraform shows you that 10 resources are going to be created, because I'm doing a greenfield deployment right now. So we are going to deploy that by using the Terraform apply command. As you can see, we are running the Terraform apply changes because we saved our execution plan with the name changes, and by using the Terraform apply changes, it's going to deploy that specific execution plan. And when everything is being run successfully, Terraform shows you that 10 resources are created. When we go to our portal, you will see that all the resources are already in the portal. So our deployment has been successfully, and every resource of our IoT data solution has been created with all the configurations that we defined in our Terraform configuration files. So where does ARM templates come in this entire Terraform story? I'm going to show you with the live demo how to deploy a specific of how we are going to deploy vulnerability assessment and Azure Defender for a specific SQL database by combining Terraform and ARM templates. All right, so as you can see, I'm opening my Visual Studio Code. You can use whatever integrated development environment that you want, but for me, I'm always using Visual Studio Code. And we are going to deploy Azure Defender for our specific SQL database, and we are going to assign vulnerability assessment. So when I go to the code to deploy an ARM template, you can see right here that this is the, excuse me, this is the Terraform code to execute a specific ARM template. So let's break this down. Of course, we are going to create a resource. We tell Terraform we want to do an ARM template deployment, and I'm going to name this ARM template deployment Azure Defender SQL database. I'm going to create it under the specific resource group, and I'm referring to a specific ARM template file which I want to deploy. This is the same ARM template file that I've shown you in the beginning of the presentation. And as you can remember, I've defined 4 parameters for that specific ARM template, which was the server name, the database name, the storage endpoint, and the email addresses. Because we want to enable Azure Defender of a specific SQL database, and then we have to know which kind of SQL server that is, and also which database under that SQL server we want to enable that for. The third parameter is the storage endpoint, because when you enable vulnerability assessments, Azure SQL database needs a storage account to store all the vulnerability assessment logs. So we are going to extract a specific connection to a storage account that we created also in our IoT data solution. And I want to be notified. So when a vulnerability is happening, I want that dummy@hotmail.com is being notified that there are vulnerabilities. So when we go to the ARM template, which is right here, you can see the 4 parameters that we defined, and also the 2 resource blocks that tells Terraform, tells Azure to enable vulnerability assessment and Azure Defender. So the first resource block is the one to enable Azure Defender on a specific database. And the second one is to enable vulnerability assessment and also add the email addresses for the notifications. So right now, the code should be fine. And we are going to run this deployment locally. And for that, I'm going to run the exact same Terraform commands that I've shown you in the presentation. So first, we are going to begin by initializing the Terraform solution. After that, I want to list the workspaces, and I want to select the event demo workspace because that's the one that contains the IoT data solution. And after that, I'm going to run the list command again because I want to make sure that the specific workspace is being selected. Right. As you can see, I'm going to run the Terraform plan command, which is going to show me that Terraform wants to deploy an ARM template. And if everything is okay and nothing's being deleted for some reason, I can make the deployment. So as you can see, there's going to be created one resource, and one resource is going to be customized. This is the ARM template deployment. So everything looks fine. So right now I'm going to execute the deployment. And when I go to the portal, let's make a check first that Azure Defender is disabled. When I go to Security Center for the specific Azure SQL database, you will see that the Azure Defender for SQL is disabled. So while this code is being executed, I'm going to show you the IoT data solution and verify that some of the configurations are actually deployed. So as you can remember, for the function app, we defined some application settings to automatically configure the connection between the IoT hub and between the data lake. So when I go to the Azure Function app and I'm going to open the configuration, you will see that that specific configuration has been registered on the right way. So the IoT connection string is already configured to our function app, and also the data lake Gen 2 connection string is already configured. So everything has been deployed exactly as we defined in our Terraform configuration files. So let's go back to the execution. All right, the ARM template deployment is still being ran. When I go to the Azure SQL database, it should already be enabled. And as you can see, Azure Defender for SQL is now enabled at database level. When I open the configuration settings, you will see that vulnerability assessment is enabled, and also that the email addresses that we listed in our ARM template deployment are already configured to vulnerability assessment notifications. So in this way, you can easily deploy an ARM template by using Terraform and combine those two tools together. And exactly as our terminal is going to say, the resources has been created, one resource has been added, and one resource has been changed. So back to the presentation. Another recap. During the previous slides and demo, I have shared how to provision and configure a data solution in Azure by using Terraform and by live demoing an ARM template deployment and combine those two tools. Next up, we are going to provision and configure this same solution, but by using Azure DevOps and not doing it locally. So first, we have to set up our Azure DevOps environment, and we are going to deploy the same exact solution, but now by using Azure DevOps. So how do we do this? First, we have to create an Azure repo, which contains all our Terraform configuration files. And when you created those in your, for example, in Visual Studio Code, you can run certain Git commands to commit those configuration files to your Azure repository by using these three commands. When you have committed those files, you can see in the repository that all the Terraform configuration files are being stored in Azure DevOps. And after that, we have to install some extensions because when you want to deploy Terraform in your Azure DevOps pipelines, or you want to use some certain functionalities that are not enabled in Azure DevOps itself, you can install some extensions. For this solution, we are going to install these 3 extensions. So the third step is to create pipelines, and we are going to create a build pipeline first. And you can create a pipeline by writing a yamofl, which is basically the blueprint of your pipeline. So we're going to start with the build pipeline, and we are going to write some YAML code to define which steps our pipelines has to do before deploying the solution. So first, we are going to register the trigger. This tells the pipeline only to be executed when a change has been committed to your master branch. After that, we are going to create a pool, which is basically the server where the build agent is going to run the code or build the code and deploy the code. The third one is I'm going to add some variables. Also in YAML files, you can define some variables which you can use across your pipelines without repeating the code itself. So I'm only going to define the Terraform workspace name, which is event demo. And then I'm going to define the build job. So first I'm going to name the job, and then I'm going to define the steps that I want the build job to take. For this example, I'm using 2 template files which contains their own YAML definition, and I'm going to use some simple generic functionalities, which is I'm going to set the environment variables. As you can remember, in the beginning of the setup of your Terraform solution, you have to assign some environment variables to make the authentication to Azure. So I'm going to do that by running this template. And after that, I'm going to run the build Terraform template, which contains some validation and tests that I want to do over my Terraform solution. So when I have created the build pipeline, I'm also going to create the release pipeline. And the release pipeline defines every step that I want to take, or the release pipeline to take, to make the deployment for our IoT data solution in Azure. So we are going to start by naming the release job, and then all the steps that I want the release pipeline to take. So first, we have to install the Terraform version. For this example, I'm using a specific Terraform version. So by using the Terraform task and assigning a specific version, I'm enforcing the deployment to use the specific Terraform version. After that, I'm going to run the set environment variables again, because the release pipeline is being run on a different instance. So the environment variables are not being saved during those deployments. So I have to run the template again. Also, that's one of the pros of using templates, where you can run specific functions across pipelines without writing the code again. After that, I'm going to extract the artifact, which was created during my build pipeline, which contains the entire data solution files. So when I extracted the artifact and loaded the entire solution in the pipeline, I'm going to run the exact same Terraform commands, but now using PowerShell in Azure DevOps. But it's the same thing that we have done locally by deploying the data solution. So first, we are going to run the Terraform initialize command. Then we are going to select the workspace. And as you can see, I'm using an Azure DevOps variable, because that's the one I defined in the YAML file. And after that, I'm going to run the execution plan. And the last step is to apply the plan to make sure that the deployment is going to run. So these are the build and release pipeline definition. And when you want to trigger them, you have to make a commit to your master branch. As you can remember, it's only being triggered on your master branch. So as you can see in this image, I'm going to commit a certain change to my solution, and I'm going to commit it to my master branch and then push it to the remote repository. When that is done, you will see that the specific pipeline, which is the build and release IoT environment, is being triggered. So when I open this specific pipeline, you will see the 2 stages that are being run. First is the build IoT environment, and second one is the deploy IoT environment. And when I open a specific job, you will see all the steps that we defined in our YAML file, which we want to run in our deployment, and every step is being, you can see it right here on the image. So if the entire pipeline is being run successfully, you will see that both jobs are completed. And after that, when you go to your Azure portal, you will see that all the IoT resources are being deployed in the same exact way as when we did it locally. All right, so this concludes my session. A short summary of what I have shared this afternoon. I've shown you the what and why of infrastructure as code by using and also using Terraform and ARM templates. I've shown some Terraform commands. I've explained the predictability and repeatability benefits that you have when you use infrastructure as code. I've shown you how you can define your entire IT solution in infrastructure as code tools, the speed and flexibility that comes with using infrastructure as code, and also the ability to manage your entire infrastructure and version it. Secondly, I've shown you how to deploy an IoT data solution by using infrastructure as code tools. I've shown some certain Terraform commands, Terraform expressions which you can use, for example, the enforcement of the naming conventions for every resource, the use of Terraform variables to customize your deployment without changing the code itself, and last, by generating an execution plan and the deployment. The third step of the last part that I've shown you is how to deploy this specific solution again, but by using Azure DevOps and not doing it locally. I've shown you how you can commit your Terraform configuration files and ARM template files to Azure DevOps, how you can create your source control and repository, how you can define some simple pipelines to build and deploy your entire solution. Yeah, that's about it. So I want to thank everyone for the time and listening to my session. And I think we can start with the questions if there are any.
Yeah, thanks, Sjoerd. That was really, really great. Actually, there aren't too many questions in the Q&A yet. Maybe the attendees will use the time and put some more questions in. What if I might start with a question of my own? As I mentioned before when we discussed that, I'm aware of the possibilities, but I didn't use it too much myself. So what you showed was really straightforward, and thanks for the overview. If you would summarize your experiences, is there something where you say that are maybe the hardest steps when you get started with this? Is there something which gave you troubles in the beginning?
Yeah, that's a good question. Of course, I'm zooming in on all the benefits, but there are also, there can be some obstacles when using infrastructure as code, not specifically Terraform or ARM templates. One of the challenges that you have is that when you embed the use infrastructure as code, you will have to make sure that your IT operations, your DevOps processes, and also your system administrators or any kind of role that manages environments, they will have to know the infrastructure as code. They will have to, they need some knowledge about how that specific infrastructure as code tool works, and also how to use it. Because when a database administrator wants to change some configuration about the specific SQL database or other kind of database technology, it will have to, he or she will have to have some knowledge about the infrastructure as code. Because when you use infrastructure as code, partly, and so you, for example, you have a team of 10 administrators, and 5 of them uses purely infrastructure as code tool, and the other 5 do the configurations manually, then you will encounter some configuration and deployment problems. Because when you change some configurations manually, and then you're going to deploy it by using infrastructure as code, you will have the possibility that you will override some certain configurations. So it's very important when you make the decision as an organization to use a specific infrastructure as code tool, that all the people are going to be trained in that specific technology, but also that your IT operations and Azure DevOps processes are also going to use this way of work. So that's I think it's not a negative point, but it can be an obstacle. So you have to embrace that kind of work as an organization, or otherwise it can maybe slow you down.
Yeah.
So for me, that was that's one of the hard things about using infrastructure as code tools. But when you embrace that technology and uses it as a team, you will see the benefits are incredible, especially when you are using different data solutions and you want to, for example, create structured deployment processes, and also change some specific configurations. Then you will immediately see the benefits of using these tools.
Yeah, that makes absolute sense. Maybe to come back to one of the points you just mentioned, I would be one of the persons trying to still change settings manually in the portal instead of using infrastructure as code at the moment, at least. And you mentioned that communication and actually working on a common agreement is very important. You also mentioned policies during your session. And I remember from different projects that you can use policies to enforce, for example, certain things like you need certain tags or something like that. Could you use policies also to prevent manual changes, or at least at some level? You know that? Actually, I know that's a very specific question. I was just wondering, because you were mentioning that manual changes can conflict, or more or less you could override manual changes. I was just wondering if you know if that might be possible.
That's a good question. I know that with Azure policies, you can enforce some policies by when somebody creates a resource, it has to be created in a specific region. But by enforcing a policy to prevent manual changes, I don't know if that's possible. I can't answer that, but it's an interesting question. I can imagine why I think of that. Yeah.
So maybe it could be something like you have a development subscription where people are also allowed, for example, to change, and you could enforce it for test and production by only allowing, let's say, a certain team to be contributor to do the changes, and those would run the changes using pipelines, and development, they would have to live with the conflict that people might change something manually. And
yeah, so that's very important. But the sky is the limit, especially when using, for example, tags. I've also shown that in the deployment of the IoT solution. When you can assign some certain tags, and you can use Azure policies to enforce those policy on resources that has some specific tags. But you can also, for example, when you want to monitor the entire performance of your solution, you can store those performance data in your log analytics workspace, and you can extract that data of those specific resources by using the tag. So you can use it for not only policies, but you can also use it to enhance your solution, or to do some monitoring in a better way that maybe already is being displayed in Azure. So yeah, you can do whatever you want. And for example, I think it's very cool when you deploy an infrastructure, but also to make sure that if you have a production environment, which is very important to a company, and when, for example, hundreds of dashboards are being run on your solution, and business critical processes are being run, and when somebody makes a change and something happens, when you do that manually, it's very hard to refer that change back if that person maybe forgot about it, or the problem is being signaled a month later. And by using infrastructure as code and DevOps, you can simply refer it back and see what kind of change has been done, which causes the error. So there are many benefits, but also, you have to embrace this kind of technology and integrate it in your way of work.
Makes sense. Thanks a lot for all the answers. Actually, there are no more questions, but I think that is only a sign that your that your session was so clear and straightforward. Thanks so much for the interesting topic. And yeah, thanks everyone for attending. And thanks, Sjoerd. Have a great day and a great weekend. And I hope I see you soon with on other conferences and with other topics.
Yes, definitely. Thanks everyone. And if someone has a question later on this day, or maybe a few weeks later, you can contact me in the contact details in the presentation, and maybe I can help with some cases or give some advice, or maybe you can help me when you have some better points. But yeah, thanks everyone. Thank you for this opportunity, and have a nice day.
Yeah!